Hello, my dear students and the rest of the learners. Welcome to part 4 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this tutorial, we are going to learn about what we call the variables, the constants and data types that are found in C programming. My name is Memenji M, or you can simply call me Emily Swap. What are variables and the data types? A variable is a memory location whose value changes during execution of a program. A variable is declared by specifying the item's data type followed by the variable name. In other words, my dear students and the rest of the learners, anytime you are writing a C program and you know that you are going to request the user to enter a certain value, that value needs to be stored somewhere in the computer memory for use. In addition, if you want to store a certain value in the computer's memory during processing, so that then you can be able to make use of that value in that memory during processing to perform a certain task, then you have no option but to set some memory locations assigned to hold those values. And therefore, what we are calling a variable, it is simply that memory location that you have set assigned to hold a value, and the content of that memory location can change. In other words, you can set a memory location assigned to store values, and those values can be changing during program execution. And therefore, that memory location that you have set aside to be used for holding a certain value during processing time is what we are calling a variable. So, how do you tell the compiler to set a memory location assigned for you to use? What you do is you need to tell the compiler, you need to inform the processor what type of data is going to be stored in the memory that you want to set aside. That is what will help the compiler to be able to know the amount of memory that is going to set aside, how big or small that memory will be. You do that by informing the compiler about the data type for your memory. And therefore, you set a memory location aside. That is declaring. To declare is to tell the compiler to set some memory location aside. And therefore, how do you tell the compiler to set some memory location aside? You tell the compiler to set memory location assigned to be used to hold your value by informing it about the data type that will be stored there, or the type of data that will be stored there, and the name of that memory. So you inform it the name of the memory and the type of data that the memory will hold. So declaring, just as I've said, means telling the compiler to reserve memory locations in which the values for the data items are to be stored. A data type is a set of values that can be held in memory location and a set of operations on those values. What we are simply saying, or what I'm informing you, my dear students, and the rest of the learners, is that it is the type of data that is held in a memory location that will determine the activities that will be performed. For example, if you are storing a number in a memory location, then you can perform certain activities on that number. You can perform some computations. You can do some additions. But if in a memory location, you keep or you store in it, for example, a name, a text, for example, Julius, you cannot add Julius to 10. So the type of operations or activities that the compiler can be able to perform on the data you have kept in memory is determined by the type of data, or what we call the data type for that memory. So the three main classifications of data types that are used in C programming are what we call the simple data types, the structured data types, also called non-primitive, composite, or derived data types. And number three, we have what we call the user-defined data types. So what are simple data types? Simple data types are simply those data types that are inbuilt or predefined in C programming language. So the following is a list of those data types that are already known by the processor. They are already known by the compiler, and their details indicating the data type, the size in bytes or how big or small that data type is, as well as its minimum and maximum value. So the first data type or type of data that can be held in a memory location is the car. So car or side car. Now the maximum size of that data type is one byte. 1 byte, simply meaning one character. Like in the name Julius, it is J. Now the minimum size in terms of bytes that car can accommodate is negative or minus 128 and the maximum of 127. So this simply means that the content of car memory can be any value between minus 128 on the lower side to a maximum of 127. Now, why is size important, my dear students and the rest of the learners? It's always good to choose the accurate data type because each data type has its own size. So depending on the size of the value that you want your memory location to hold, that will tell you which data type to select. The second type of data or data type is assigned car. Its maximum value is 1. That is one character. In other words, 1 byte. And it can accommodate maximum of 0, and that is minimum of 0 and maximum of 255. Then the third data type is called int. And remember, this is exactly one thing that you use when we're specifying data type. Car, and side car, int, or side int. Now, int can allow you, or its size is 4 bytes. 4 bytes. And the minimum amount of value that memory location can hold is negative 2,147,483,648. And the maximum is 2,147,483,647. Already you can see that in terms of size, though these are different data types, int has a large size than car. But of course, remember, car is for character. Int is for whole number. The fourth data type is unsigned int. You can see, whereas its size in bytes is 4, the minimum this memory can hold is 0. And the maximum is 4,294,967,295. So the difference between this data type and this data type is that this data type will accommodate negative numbers, but this other one will not. So if you are going to make use of integer, remembering int is a data type that accommodates whole numbers. note that if you want to accommodate the negative numbers between int and unsigned int, the best one is unsigned, the best one is int, because it will allow you to have negative values. But if you use unsigned int, it will only accommodate numbers between 0, 4 billion, 294 million, 967,295. The next data type is called short int. Its maximum size in bytes and the values it can hold is minimum of negative 32,768 and the maximum of 32,767. Therefore, my dear students and the rest of the learners, you can see short int allows fewer numbers than assigned int or int. Very important that you must choose your data types accurately. Don't choose a data type that allows big numbers if you're going to make use of small numbers. And don't choose one which is small if you know your program will prompt for large numbers to be stored. The next data type is unsigned short int. You can see its maximum size in bytes is 2. Minimum value it can accommodate is 0, and the maximum is 65,535. Then we have long int or signed long int. You can see its maximum size is 4 bytes, and it can accommodate values spanning from negative 2 billion, 147 million, 483,648 to a maximum of 2 billion, 147 million, 483,647. As you can see, between long int and int, between long int and int, and between long int and unsigned int, you can see there's a whole difference. If you look at long int, it will allow maximum of 2 billion. But if you look at unsigned int, it will allow maximum of 4 billion, 294 million, 967,295. But it is not accommodating the negative values, but this one is allowing. Then we have unsigned long int. Unsigned long int is maximum of 4 bytes. It allows minimum of 0 and a maximum of 4 billion. So you have to choose your data types wisely. The next data type is float. Float is allowing maximum of 4 bytes. And this one allows numbers with decimal points. And you can see that those numbers can range from 3.4 raised to power negative 38. That means those are very many numbers on the negative, decimal points, very many decimal points, and to a maximum of 3.4 raised to power positive 38. So that tells you that when you choose float data type, it will allow data or numbers with decimal points. And those decimal points will span from 3.4 raised to power negative 38 to 3.4 raised to power positive 38. The next data type is double. Double is allowing maximum of 8. It has a size of 8 bytes. This is very big, 8 bytes. And the minimum value it can accommodate is 1.7 raised to power negative 380. My dear friend, my dear students and the rest of the learners, you can agree with me that when you declare a memory location assigned called double, you hold or you tell the compiler set a lot of memory location assigned. And the maximum value is positive 1.7 raised to power positive 380. That's huge. If you choose this type of data for smaller values, I can tell you, you will be wasting a lot of computer's memory. And you need to manage your memory wisely. So choose the correct data types. We also have long double. Its maximum size is 8 bytes. And it is able to accommodate the data which is equal to the one for double data type, as you can see. The last one, data type, or the last data type is called Boolean or bool. Its maximum is 1 byte. And it only allows minimum of a 0 and maximum of a 1. That is a true or a false value. Therefore, my dear students and the rest of the learners, it is important for you to note the following, that the data types for characters are car or signed car or unsigned car. And it allows a maximum of 1 character. So that tells you that if you have a name which is more than 1 character, you have to make use of what we call an array of characters, which you are going to discuss later. Then the data types for whole numbers. The data types for whole numbers, whether positive or negative, are int, signed int, unsigned int, short int, unsigned short int, long int, signed long int, and unsigned long int. So those data types are for whole numbers, I repeat. The data types for holding characters are car or signed car, unsigned car. Then data types for holding whole numbers, numbers without decimal points, depending on the size you want, and spanning from the negative to the negative, the positive, are int, signed int, unsigned int, short int, unsigned short int, long int, or signed long int. Then, if you want to store, of course, plus unsigned long int. Then, if you want to set memory location assigned to hold the values with the decimal points or fractions, then you make use of data types such as float, double, long, double. I repeat, float, double, long, double. But note, choose the data type wisely. Don't choose data type which will allow very many numbers or numbers which are huge, yet you're going to use it to store small numbers. And don't choose another type which allows a small value if you want to hold large values. And then the data type for true or false, or what we call the Boolean, is called bool. Now, if you are going to store data which is composed of characters, as you have seen, the car data type only allows you to set memory location assigned to hold a single character. But ordinarily in real life, you need to set memory location assigned to hold a set of characters. For example, a name of a person, name of an institution, a name of an object. A name is composed of several characters. So because we don't have a data type in C for holding several characters at once, how do we go about it? So there's what we call the strings. So a string is a collection of characters. Therefore, due to the fact that C does not have a data type called string, strings are declared with the use of array of characters. That is, using car data type with the following syntax. Car, variable name, that is the name of the memory location you want to set aside, and then you specify the number of characters that you want the compiler to set aside. For example, if you want to request the compiler to set memory location assigned to store a name which does not exceed 25 characters, like first name, then declare it as follows. Tell the compiler to set memory location assigned for holding data type or data of type char, that is character. Call that name of that memory location first name, and then size 25, meaning You are requesting the compiler to set memory location assigned to hold 25 characters or data of type char, but maximum of 25 characters, and give the name of that memory location, the name, first name. You then assign a string to the variable as follows. So once you have set the memory location assigned, for example, called first name, you can assign into it some text, but note, you must enclose that text in double quote. For example, this statement tells the compiler to assign or store the text name Julius in the memory location which has been set aside called first name. We can declare and define an array of characters and initialize it with a string constant in C as follows. So we can also assign a string set of characters into a memory location. Now, in a situation where you are going to set or assign or store a predefined string or set of ones in a memory location for type char, you don't need to specify the number of characters that memory location will hold. Like as you can see in this statement here, you can see that I have not enclosed any character, any number inside here. Why? Because the compiler will count straight away these characters, and that is the type of memory or the size of memory that it is going to set aside. Therefore, this set of ones is what we are calling a string, a constant, because that constant, that value is not going to change. So let's look at what we call structured data types. What are structured data types? These are data types that are created by grouping the simple data types together to form new data types such as arrays, structs, and pointers, sets, and files. So this simply means that you can create a data type that combines several primitive data types. We are going to learn about that later in the subsequent part of the series in C programming. The third type of data or data type is what we call the user-defined data types. These are data types created by the user by combining multiple elements of other types and defining the valid operations of the new data type. These data types include subranges, enumerated lists, and are defined in C using the reserved word typedef and enum. So, a variable name, or what we call identifier, is a name given to a memory location whose value is allowed to change during program execution, just as we have learned. It is used to identify the memory location set aside to store values. The four main rules for identifiers are, in other words, whereas you have said it is important to set memory location assigned to hold a certain value and give that memory location a name, there are certain rules that governs how you do the naming. One of those rules is that you must never start a name of a memory with a number. You must never start a name of memory location with a number. Number two, every variable must start with a letter of the alphabet. So when you are naming your variables, ensure the name of the memory location you are setting aside, that name starts with a letter of the alphabet. For example, A, B, C, D, or A, B, Q, D, etc. Number three, it should not have spaces between them. So if, for example, you want to set a memory location aside called first name, whereas it's okay that you want to have a memory for holding your first name, remember, you should not have a space in between. So you write the name first name as a single word, or you write first underscore name. Number four, the name of a memory location should not have special characters. So don't include special characters like comma, exclamation marks, asterisks, forward slashes, etc. Let it be purely a mix of number or a mix of numbers and letters of the alphabet, but ensure that if you're going to make use of a number, it does not be in the name, does not be in the number. So for example, you can have first name 1, first name 20, but it should not be 20 first name. So the two types of identifiers in C are the standard identifiers and what we call the user-defined identifiers. In other words, when it comes to naming variables, there are certain variables that are already known by the processor, and there are those which you give by yourself. So what are standard identifiers? These are names that have a predefined meaning in C, but can be redefined by the programmer to serve different purposes. In other words, these are names that have a predefined meaning. For example, scanf, gets, printf, puts, amongst others. Those are standard identifiers, and they are already known by the processor, and they are used to do or perform specific functions. Then we have those which you create by yourself. Those are called user-defined identifiers. These are the names that have no predefined meaning in C and are used by a programmer to identify the memory locations set aside to store values and name operations that he or she defines. So, what is the syntax for declaring a variable? The syntax for declaring variable, or the format that you use when you want to communicate to the processor to set memory location assigned to hold a certain value, is as follows: data type, space, variable name or names, and a semicolon. For example, car, your name, 20, semicolon. This is a string or array of characters. You can also declare several memory locations aside using the same statement if the type of data that those memory locations are going to hold is the same. For example, this statement tells the compiler to set memory location assigned, two memory locations assigned, one called future age, the other one called age, and both of them are to hold data of type integer or whole number. So this statement declares multiple variables as a single statement. So a variable can also be initialized during declaration. In other words, you can request the compiler to set memory location assigned of a certain type and store into it a certain value by default. That is called initialization. So what is initialization? Initialization is the process of giving a variable some initial value during declaration. So the following are some examples of initialization in C. For example, if you have set the memory location aside called your name, as we have seen, and it's of type char, whose maximum number of characters should be 20, you can assign text into it, as you can see. So this statement performs a number of activities. This statement is telling the compiler to set memory location assigned called your name, which is supposed to hold characters which should not exceed 20. Set the memory location assigned called your name that is supposed to hold a maximum of 20 characters, then assign into 8 or store into 8 the text meme Emily swap. This other statement is declaring a memory location called age, which is supposed to hold data of type integer or a whole number, and it is telling the compiler, once you have set this memory location assigned called age to hold a whole number, store into it 13. Let's now look at what we call the constants and data types. What are constants? A constant is a memory location whose value does not change during program execution. So a constant is opposite of variable. We have seen that variable is a memory location which you set aside and can hold various values during program execution. But constant is different. A constant is a memory location that you set aside to hold a value that does not change during program execution. So once you have assigned a value into it, that value will not change during the program execution. So the method or the way of declaring a constant is almost similar to the way you declare a variable, but now you precede it with the word const. So the syntax is const, which is a reserved word, followed by the data type, the type of data that that memory is supposed to hold, and then the name of that memory, and assignment operator, and the value that you are assigning into it. For example, you can have const int age equals to 20. So the definition of a constant is achieved by using the reserved word const. Constants can be defined using any of the following syntax in C. So just as I've said, you can use the reserved word const followed by the data type, then the name, and then assignment operator and the value. Like this statement tells the compiler, set memory location assigned called years, which is supposed to hold a value, a whole number that does not change, and this whole number is 10. The other way, the second method of defining a constant is using the one define. So hash define followed by the name of the variable, the name of the memory location, the name of the memory location, and the value you want to assign there. For example, hash define years 10. You can see there's no equal sign, there's no assignment operator. It's simply you are telling the compiler to set memory location assigned called years, whose value is 10, and that memory location of that value does not change during program execution. So the following is a sample program that implements variables, constants, and data types to determine the selling price of a product after a discount of 5% and calculates the customer's balance after making payment. So we begin with the comment. The comment is program to compute sales, discount, and balances. Then we have hash include stdio.h. We have int main. Then we have the opening brace there. And then we are setting memory location assigned. And these memory locations we are setting assigned are supposed to hold data with the decimal points. So this statement is setting the following memory locations assigned. The names of those memory locations are price, discount, amount, total, cash issued, balance. So these are 6 variables which are supposed to hold data of type double. Then we are declaring a memory location called discount rate that is supposed to hold a value that does not change, which is 5. Now note, because this data type is float, you can have it as 5.0, but even if you don't assign a value with a decimal point, by default, a value like 5 has a decimal point of 0. Then we are setting another memory location assigned called the quantity, which is supposed to hold data of type integer. Next is inputting selling price and the quantity bought. So this is a comment. So the next statement here is we are prompting the user to enter or to input the item selling price. So the statement which will be displayed on the screen is input the item's selling price. Then the user will key in a value, and that value will be read and it will be stored in memory location called a price. And that value can have a decimal point, for example, 50.45. Then the next statement to be displayed on the screen will be input the number of items purchased. That's what printf here does. Then the user will key in a value. The value which will be entered by the user through the keyboard will be read and stored in memory location called quantity. And as you can see, that value should be a whole number. The next section is for doing calculations. So this is the comment, computations. So this statement picks the value in the memory location called quantity, the value which has been entered by the user, multiplied by the value in the memory location called the price, and the product or the result of that multiplication will be stored in memory location called amount. The next statement picks the content in the memory location called amount, multiplies that value with the value or the value in the memory location called discount rate, which you have seen is 5. So 5 over 100. So the value in the memory location called amount will be multiplied by 5%. And the result will be stored in the memory location called discount. Remember, these are the memory locations I'm talking about. This is memory location called discount rate, and we have stored it 85. Then, as you can see, the rest of the statements are simply for computations. So the value in the memory location called discount rate, that value there is 5. So that is 5 divided by 100. So that is multiplied by the content in memory location called amount, and the results are stored in the memory location called discount. Then the next statement is to pick the value in the memory location called amount, subtract from it the value in the memory location called discount, and the result assign it in memory location called total. From there, the next section is this a comment for outputting. I'm simply informing you that the next statements here are for displaying our results on the screen. So the first statement here is it will display the statement total cost for the items bought. So it will display those set of ones on the screen, total cost for the items bought. And then this section percent 7.2 LF, comma amount is telling the processor, the compiler, to go into the memory called amount, read the value there, and display it here on the screen, formatted into maximum of 7 characters, and decimal points of 2 decimal points. So the statement will read as follows: total cost for the items bought, for example, 550.0250 etc. But the total number of the size of the digit, the number should not exceed 7 characters. And then the next statement will be, what will be displayed on the screen is discount qualified for. Discount qualified for. So those set of ones will be displayed on the screen, and then the compiler will go into the memory location called discount, read the value there, then display it on the screen, formatted to maximum of 7 characters, but with 2 decimal points. So the statement will read, for example, as discount qualified for 105.75. That's just an example. And then the next statement will be displayed will be amount to pay. So those ones will be displayed on the screen. Amount to pay. Then the compiler will go to the memory location called total, pick the value which is there, and display it at this point. So it will read, for example, amount to pay 79.72. As an example. And the next section is to compute and display the customer's balance. So the statement, which will be displayed on the screen now, is enter cash amount issued by the customer. So this is where now the user will give some value or some money to the seller. So if, for example, the user issues 1,000, the cashier or the person who is keying in will type 1,000. So that 1,000, that value 1,000 will be rent and be stored in memo location account cash issued. Then from there, this statement computes the difference. So what does this statement do? It is telling the compiler, go to the memory location called cash issued, pick the value which is there, then subtract what is in the memory location called total. And the results, assign them in the memory location called balance. Then from there, this statement is telling the compiler to do the following. Display the following text on the screen. Amount paid. Go to the memory location called cash issued. Pick the value which is there and display it on the screen, but without exceeding 7 characters, and the decimal point should not exceed 2. So if, for example, what is in the cash issued memory location is 1,000, the statement will read as amount paid 1,000.00. The next statement, which will be displayed, is customer's balance amount is. So those ones will be displayed on the screen. Customer's balance amount is, and then the compiler will go to the memory location called balance, read the value which is there, then display it on the screen at that point. And that marks the end of the program. So this statement is saying the compiler to take back the control, the operating system, and end the program. So my dear students and the rest of the learners, this is a very good program that is teaching you about variables, constants, and data types. So the variables we have come across include these are variables. These ones are variables, and data type is double. The names of the variables are price, discount, amount, total, cash issued, balance. Then constant, like discount rate, that's a constant. Then other data types or variables include the quantity. So with that, my dear students and the rest of the learners, we can now code this program in our IDE so that you can see how it will behave. Let's see whether this program will behave as I've explained. Remember, you can write this program in your exercise book, then code it in your IDE or type it in a word processor, then copy it and paste it in your Falcon IDE. So how do we go about this activity? We are going to load our Falcon C++. We start a new file, and then we are going to do our coding, and we run our program from there. So what we need to do is we are going to click on the Start menu. Then under Search, we can type Falcon. Falcon. Because it is installed, the icon will appear there. You just click on it. Now, once you are here, we can then proceed and create the name of our file. So first of all, we need to create our project. So I'll click on the file, go into new, then I'll click on the project. I'll click empty project and then next. The name of my project will be sales. I will call it sales. And then compiler type is C. Then I'll click on finish. So we have our project here. It is sales. So let me create a file here. So right click on my project, which is sales, point on new, and then I'll click on C file because I'm creating a C file. You can see by default, it is given the name main, but it's always going to give you a file, a name which is meaningful, a name which portrays what your program will be doing. So I'll right click on it and click on the name. The name I want to give it is computing. I'll call it computing sales as one word. Computing sales. Then I'll click anywhere outside there. So you can see my name is there. So the next thing I want to do is to pick that program I've explained to you and paste it here. Or if you want to type, you can just type it directly on the IDE here. So once we are in our IDE, that is the editor for our IDE, if you had already typed your program using a 1D processor, you can just copy your program and paste it here. This is the program that I've already explained to you, my dear students and the rest of the learners. However, remember that you can always type your program directly on the IDE, though that is not advisable. As a good programmer, it's always good to train yourself to be writing down your program in an exercise book or in a 1D processor. Then run your program from there. See whether the logic is okay. See whether the syntax is okay. And then when you come to your IDE, you just retype your program there or just paste it here. Remember, the purpose of us coding our program in our IDE, in our editor for our IDE, like Falcon, is simply to enable us compile this program and execute it. And therefore, you don't need to come and begin typing your program from scratch in your IDE. In as much that is okay. You can also always develop your program in a piece of paper, and then when you come to your IDE, you just use it to perform the activity you want to perform, the core work, which is compiling your program and executing your program, together with doing any debugging, which you might not have noted. So once you have coded your program here, remember, it's always good for you to indent your program nicely. So if you look at my program, my dear students and the rest of the learners, you can see I have added comments. Every part of my program has some comments. Every part of every section has some comments. Then the type of variables I'm making use of are meaningful. For example, price, discount, amount, total, cash issued, balance. You can see discount rate, quantity. So when you are making your program or when you are coding your program in C, always make it as user-friendly as possible and as readable as possible. And what are some of the ways of making your program readable? One is to add comments at the respective points. Secondly, it is to indent each part of your program appropriately. And also do accurate spacing. Like you can see, after every section of my program, I have a space. And then, of course, use names that are meaningful, as you can see. Once you have coded your program, you have used the appropriate data types, you have given appropriate variable names. If it's for variables, you have done that. If it's for your constants, you have declared them well, and you have chosen your data types correctly, then you can save your program. So you click on File menu and click on Save. Now, if you look here, have I clicked on Save or Save As? Let's repeat and see. Click on File menu, then click on Save. So you can see I've been brought to the save screen. So you can browse to your folder where you want to save your file. My folder is already selected. So I'll click on Save there. So that's my program. I have saved it. So from there, you can click on Run menu and then click on Compile. As you can see, our program compilation is successful. As you can see from this status menu here, or status bar. So our program has no errors. From there, once your compilation is successful, you can now run your program by clicking on Run menu, then you click on Run. Let's see. So once you execute your program or you run it, you'll be brought the output screen. You can see, just as I've said, the first statement here is input the item's selling price. So let me type item selling price as 1,250. Then you press enter. After you press enter, what do you expect to see? You expect the next statement to be input the number of items purchased. So let me press enter. So that's the cost of one item. Now, how many number of items are you purchasing? For example, I can type 4. Then press enter. You can see the next statements that have been displayed is the total cost for the items bought. Already, the processor has been able to compute the amount to pay, the discount required, and the total amount to be paid. So you can see the statements which are displayed now is total cost for the items bought is 5,000. Why? Because already some discount has been given. Now look here. Items selling price is 12.50. The number of items purchased are 4. So if you multiply 12 by 1250 times 4, it will give you total cost of 5,000. And then you can see there is a discount allowed. So the discount qualified before is 250 as from my computation or from the program, because discount is equals to amount times 5%. So if you pick 5,000 multiplied by 5%, you are going to get 250. And then the total now to pay is total, which is 5,000, subtract the discount. So the amount to pay is 47.50. The next statement now is prompt the user to enter the amount issued by the customer. So how much is the customer going to give? So if, for example, the customer gives out the total of 6,000, so you type 6,000 there. So that is enter cash amount issued by the customer. So the customer gives out 6,000. So you press enter. You can see the program is then displaying amount paid 6,000. Now customer's balance amount is positive 12.50. So this simply means that this money is extra. This is what the user needs to be refunded, 12.50. And that is the end of the program. What about if the user enters a different amount? Let's run our program again. Input item selling price, for example, 670. How many items is the user purchasing? P10. You can see total cost for the items bought, 6,700. Discount qualified for 335. You can see the logic is the same. Amount to pay is 63.65. That means the user has been given some discount. So enter amount issued by the customer, assuming the customer gives out 5,000. What will be the customer balance? You can see the customer balance amount paid is 5,000. So customer balance is as a shortfall of 1365. So the customer will be requested to enter, to give out some more 1,365 because there's a shortage in the amount paid. The amount paid is less than the required amount. So my dear students and the rest of the learners, this is a very wonderful program for you to use. This is type of program that is used in most of the supermarkets, payment points. That's how that program works. And therefore, my dear students and the rest of the learners, having learned about what variables are, what constants are, what data types are, then the next thing is for us to learn more about how our program is working and how to do more in our program, or to explain more about what each of these parts do. And therefore, it's always good to save the program and then you close all and exit from the program. And with that, my dear students and the rest of the learners, we have come to the end of part 4 of the series. You can now proceed to part 5 of the series, in which we are going to learn about what we call the input and output statements that, of course, we have been using in the entire series of our programs, in the entire series of videos, even though I have not explained each of them by then. So as we proceed, we are going on learning more about the parts of the previous programs, including parts of this program that we have discussed, so that by the end of the day, my dear students and the rest of the learners, you will have become excellent in the way you write your programs in C. Therefore, receive congratulations for learning part 4 of 29 on variables, constants, and data types in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on EmeliSwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me, and let's meet in part 5 of the series, and God bless.